All right, this is lesson 8-2. So, because our graphing method is not a very reliable, accurate method, we have 3 different methods we could use. The graphing method, solve by graphing, solve by substitution, and solve by elimination or addition. That's the same method. Today we're working on substitution. There is no graphing. If you graph, you're not learning the method. All right. We use substitution when it's easy to get one variable alone. Of those 2 equations, is there a variable alone? Rogelio? The y. So, if y equals 2x, then anytime I see a y in any equation, I could substitute a 2x. So I know that this y is equal to this chunk here, 2x. So I can substitute that when I see one in that y. X plus 2x instead of y, because they're equal, is equal to 6. What I've done here is eliminate one of the variables, and then I can solve. Because really we're looking for the same y that works in both. And now we simplify, combine our like terms. You should all be writing this. And divide both sides by 3, and we get x equals 2. So now that I know my x is equal to 2, what am I looking for? What's my goal here? Sarkis.
Find y.
Not just to find y, but overall, what's the goal here? What does it mean to solve the system?
To find out what x and y are.
To find the ordered pair where they both intersect. The solution where they both intersect. So now we have to find y. What do you think I do, Sarkis?
You multiply x by 2.
I substitute x by 2. Right? I'm going to substitute the 2 in for the x, now that I know what x is. And we multiply 2 times 2, and we get our y. So what is my solution, please? Luke? 2, 4. Make sure you put them in the right ordered pair way. Now, the best thing about this is you can check your answers. And it's not about, spending extra time, but it's really about, in every problem you do on this chapter test, chapter 8, there's a way to check to see if you're doing it right. So if you're not checking it, you're possibly leaving it to chance to see if you got the right answer. Now, the way I check it is that point should make both sides of the equation equivalent in both equations. So I can check. If I substitute y equals, or let's do this. We're doing y equals 2x. Here's the check. And then I substitute 4 is equal to 2 times 2. Substitute my x and y in. Is this a true statement?
Yes.
So it works in that equation. And then I try the other one. What is x?
2.
What is y?
4.
Does this work? Does this point work in this equation?
Yes.
They're equivalent, so they work. So, yes, 2, 4 is the solution to the equation. Okay. Questions? Okay. I'll make sure on a test you're checking. All right. Let's take a look and compare and contrast. When I have an equation like this, I solve, I graph it, I draw the line. Do the same thing here. Start at my 4, rise -1, run 3. Look at the problem here. What's the problem with that? I see all the same people are raising their hands. Peyton.
Well, it doesn't intersect at a It's hard to tell exactly where it
It's hard to tell exactly where, so we have to eyeball it. It's not a very accurate way to do math. In science, we need it to be accurate. Math is the tool for science. So we use the substitution method. It says it's about equal to 4, 3, but it's not exactly. I can get much more accurate when I substitute in I get a decimal or a fraction. Remember, decimals and fractions are the same. Then I substitute in. And this is way more accurate than about 4, 3. Yes?
Do you want us to do that on the test?
Yes. Always. If it's that section and it says use substitution, I want you to do that. Okay. For tonight's homework, it's the only way you're doing it. You're not graphing. So let's try one. Yes, sorry. What was your question? Do you see how that's a hard point to see? So what we do is we use our substitution method. Y is already alone, so I'm going to substitute wherever I see a y and x minus 1. So it becomes 3 times the quantity of x minus 1. Simplify it out, figure out what my x is, then substitute that back in for the x. We substitute it back into either of the original equations. All right. In this case, what am I going to substitute for? Oscar.
X and Y.
Well, which one in particular? What's the easiest to start off with?
X equals 3Y.
Right, and so what are you going to substitute for? What gets substituted for what?
X gets substituted for 4X.
Not 4x.
Negative 4X.
But what am I substituting in? I don't think he's understanding my question. I'm sorry. What can I substitute in this equation? Lucy.
3Y.
For?
For 4X.
No, not for 4x. For just the x. So every time I see an x, I'm going to substitute in 3y. Does that make sense, Oscar? So here, how's it going to read? How's the new equation going to read? This one right here.
2y minus negative, I don't know,
Negative. You're right.
or 3y.
4. When 4 is next to x, what operation is that?
3y times 3y.
Times 3y. Negative 4 times 3y. Absolutely. It only gets substituted for the x. The rest of the equation is written down. Okay, why don't you guys finish it up? Finish the rest of the process. Pause the recording. Let's finish this up. Now check your work. So, when I do this, I get 2y minus 12y. Now, remember, this is a positive 2y and a negative 12y. So, when they're different signs, do we add or subtract? Subtract. And next step, I'm going to divide both sides by negative 10. I have to reduce that right side to negative 1/2. Once I have that negative 1/2, what do I do with it? Same 3 people keep raising their hands. Lucy.
You plug it back in.
2.
X equals 3y.
Okay, so how's it going to read?
X equals 3 times negative 1.
Perfect. And now I'm multiplying numerator to numerator, denominator to denominator. So we end up with x equals negative 3 over 2. So what's my ordered pair? Michelle?
Negative 3 over 2,
Here's the big one. Make sure you put this in for the x.
negative 1/2.
Okay, questions? Yeah. Michael?
When you're checking your work, so you just when you're checking your work for the x equals 3y, your answer, it would be -3/2 equals 3 times negative
1/2. And your equation should come out equal.
It came out -3/2 equals -3/2.
Yeah, that's correct. That's perfect. Now, sometimes you don't have a variable alone. So what do you think we need to do? Okay, Luke? Isolate. Which one's the easiest to isolate?
The x.
Good. So I'm going to take 2y plus x and subtract that 2y. Shh. Okay, and then once I get that x alone, every time I see an x, I'm going to substitute in for it. So now it's going to read 2 times -2y plus 5. Shh. Okay, substitute it in. Make sure you're distributing properly, that you distribute into the entire. Remember, that's 4 times -2y plus 5, the entire thing. So you've got to, 2 times -2y. You've got to multiply it out completely when you distribute. 2 times -2y is -4y, and 2 times 5 is 10. Simplify, and I get -y equals -3. What do I do next? Piper?
Well, -y equals -3 is equal to y equals 3.
Right, we can just take the opposite. And then what, Piper?
And then you try to find the x by putting it back into the problem.
Okay, now, let me show you something. This equation is this equation right here and this equation right here, this equivalent. Yep. And this one already has x alone. So if I substitute here, I'm going to get x equals -2 times 3 plus 5. I don't have to do any inverse operations. I just have to simplify. X equals -6 plus 5. X equals -1. My ordered pair is -1, comma 3. Now, I could have substituted in here or in here. It doesn't matter. Any of the original equations. This is the original equation. It's just manipulated a little bit. Might be a little easier for the math. So when you get that y, you substitute it into the original equation. Questions? All right, I got one, and I need you to not leave until I finish this one next. It's a word problem, and I want to make sure we get it. Shh. So I need you to not be packing up right now. All right, so let's look at the word. You will have some word problems. Okay, Chatty Phone charges a flat monthly fee of $20 plus 8 cents a minute. Telco charges $14 plus 10 cents a minute. What is the unknown? What is varying, changing? Sarkis?
How much what time do you come for so they go?
More specific, please. Michael, can you clarify that?
I think the amount of time.
Specifically, yes.
How much?
There's a word in there.
How much minutes?
No, minutes. So, and we have to ask ourselves, what depends on the other? What becomes our x? What becomes our y? So, what depends on the other? We have two unknowns. We said minutes, and I also heard somebody say cost. What depends on the other? Sarkis.
The cost depends on the minutes.
Cost depends on the minute. So cost will be our y, because that's the depender. And our minutes will be the x, because that is the independent. Okay? Now, let's set up our equation for each company. Who can tell me for Chatty Phone? what the equation is? Someone other than Sarkis. How about Sydney? For the chatty phone, what would the equation be? Knowing, yeah, you.
For the chatty phone,
Go on.
it would be
Shh.
for the chatty phone, it would be
20 plus 8 cents a minute. How do you write that? With variables. 20 plus 8 cents a minute. What do I substitute for minutes? X. Equals what?
Y.
The total cost, right. So how are you going to write that equation?
Y equals 20 plus 8x.
Not 8
8x plus 20.
But not 8x, because this is 8 cents.
0.08x.
Yeah, 800ths x. Okay? So knowing that, what would the telco equation be? Please wait. I'm recording. What would the telco equation be? David?
It would be y equals 14 plus 0.10x.
Plus 0.1, or we say 1/10 x. And now we're doing the same thing. Substitute, please. Substituting in. And now we have to simplify. I think at this point, clear. Multiply everything by 100. So you get 2,000 plus 8x equals 14 plus 10x. And then finish solving it, because there's too much room for error with the decimals. And we get x equals 300. Wait. Wait, hold on. If x equals 300, shh. Let's look at that answer.
300 minutes is
They charge the same because they're only looking for the minutes, not the ordered pair. Okay, and that's the end of the lesson.